think it's some other section students. They have already joined and they left. So there was a delay. I already contacted the CATS department. Will rectify today itself. Okay. And today I will give a brief introduction on our subject. What is the subject name?
Software engineering.
Software engineering, right? Share one screen. What about other subjects? Other subjects already you got the Moodle link?
Yes, ma'am.
Okay. My name is Divya and our subject name is software engineering. What is software engineering? Is it visible, the screen?
Yes, ma'am.
Our subject is software engineering. Okay, before coming to the syllabus, I'll just introduce what a software engineering means, why we are learning the subject. You heard about software everywhere, right? Software. And actually, you are going to software engineers. What do you mean by software? What do you mean by software? You heard about software, you heard about programs. Then what is the difference between these two? And what do you mean by actually a software? You heard about many softwares, right? So just think about it.
It's an application, like
Give me an
almost.
application. Okay. Application software is the plenty softwares, right? It's there. Not only application system software is also software. Operating system and compilers, interpreters, all are softwares. That's not comes under application. Those are system softwares. So software is either system or utility system software, utility software, or application software, whatever it is. What is a software is? Software is set of instructions, right? A set of instructions called programs also. Then what is the difference between a program and software? We are going to define the term software engineering.
Software is consumer grade, ma'am. You don't have to mess with.
Software is
consumer grade.
It's
You don't need technical knowledge.
Customized
to
one, right? Customized one. Yeah, it's very good idea. What is software? It's not, even though it's not a definition, you is correct. Software mainly we are creating for customizing, of course, because user requirement is the main factor and we need to satisfy the user. So of course that point is there, but other than when you compare a software with a program, the difference is a program, you are writing so many programs in your lab using different languages, but your intention is to give some instruction to the computer to manipulate something, to do some manipulations, to do calculations, to do some functions. You are giving some instructions to the computer, a set of instructions you can call as a program. Then software is also a set of instruction, but it contains libraries, it contains data structures, it contains documents, documentation part. So you know about data structure. What is the data structure is? Because you where you use the data structure, you already learned data structure. So please tell me some examples on what you learned in the previous classes. Chat, I got something to store and organize data. Of course, you are using data structures to store and organize data because you need some in the form of tree, in the form of linked lists, in the form of graphs, in the form of arrays. All these are data structures. So this is data structures, and it contains data structure and other documentation part. Documentation means, what is documentation is? Because when you're doing something, because it's a teamwork, software development is not like the programs you write in the laboratory. It contains so many modules, and each and every module may be written by different team. So at last you need to integrate all the modules. So you need some information regarding the hello.
Yes, ma'am.
Yes, ma'am.
Yeah, okay. Actually, I got one call from the CATS department regarding this issue. So, okay, we are discussing about software engineering. Where we stop. Okay, data structures, right? Data structures, actually different type of data structures we are using to store and organize your data. Okay, so if you want to do some operations on the data, you need a data structure. So the data structure and the documentation. We are discussing about documentation. What is documentation? What is the need of documentation? Because we already said it's a teamwork. So every module, we divide the entire software in different modules, and we are developing the modules separately, and later we are integrating these things. And at the time, you need a complete record of the programs, means a record of the designing, analysis, what are the operations you've done on that software. Then only you can create a complete software, and once it's done, you have to hand over the software to the customer, and later in the future, you need to modify this according to the change in the customer requirements. Requirements are varying always. So that is done by another team. That will be done by the another team as a maintenance team. It's not the developer team. Though those teams are different. So they need the documentation. with the documentation, they get an idea about the software which you are developing and which you are already developed, and the developed team also. Sometimes some people may quit their job, they may they may not continue in the same project. So this time someone should replace that person. So we have to give the documentation to that person. So documentation is very important role. So all these things included in software engineering. Software engineering means it's not only a simple set of instructions. It's not only a simple set of instructions. It contains libraries, documentation. So these are some introduction parts in that I explain what is a program. Is an executable code which serves a computational purpose that you are always doing in your lab. You are very much familiar what is a program is, and software also you know, but you never think in this way, in this wide way, like what does it contains programming code plus library plus documentation, all those things. Generally, you are always saying that software, this software, but you never think about in this way. So you just we are analyzing here what is the software is. So the software contains the parts that you should. If suppose in the exam, if you ask to define the software, means this is the way you have to define software. Okay. Then you can say some examples, if system software, application software, utility. In the software also containing the same part. It contains this part: instructions, data structure, and documents. Then product, software product, is it same like hardware product, or is there any difference between software and hardware products? We are familiar with, generally we can call it as a product. Okay, then software product and hardware product, how it's different? How can you differentiate? Is there any lifetime or
You can update a software over time, but you can't with hardware.
software? Definitely, both hardware and software. Hardware, actually, we can say that this is a 10-year warranty. Okay, 10-year it will run. That type of warranty you cannot give in case of software. Software requirements will change after 1 month. So when you plot in graph, actually the graph is, it will be like this. You can see the failure curve of hardware and failure curve of software.
Ma'am, screen is not
Can you
visible.
define this?
Ma'am, your screen
Sorry?
is not visible.
Can you
It's not
share your
visible.
screen, ma'am?
Yeah, sure. Actually, I thought I already shared, but maybe I lost the connection between when the call came and the time it made. Okay. Can you explain these two graphs? What idea you're getting? It's not like exact explanation. What you're getting from this to failure curve of hardware and failure curve of software. You can see the X and Y axis, time versus failure rate. What is the difference? In failure rate, you can see how is the coming to the hardware. Can you see the pointer? The pointer, which the infant mortality, you can see, means once you develop a hardware, initially there is a chance for failure. Okay, that is very high. Initially it is very high, but once it's stabilized, you can see it's almost stable for a period of time. The useful life is up to from here to here. But of course, it will deteriorate, and after a period of time, it's going to end the life. There is no unlimited hardware. Means There is no hardware you can guarantee for another 100 years. But in software, that type of software is also there. Legacy softwares are there. That may be for so many years. It's used for some core engineering area. We are using some software which we won't change because it's connected to very complex things. It's connected to so many. It's very hardware dependent things, so it won't change easily. That type of software is also there, and some software have changed. It's changing very frequently. Generally, the requirements will change very frequently. So coming to hardware, this is an exact curve. You can say that initial failure rate is high, and again, after a period of time, definitely the hardware will deteriorate and the component failure will occur. But when coming to software, how can you define this? The failure rate and initial failure rate is same like hardware, but after that, an idealized curve we can see. But is it not that actual one? One is there are so many spikes, increased failure rate due to side effects. It is very high. It may happen at any time. There is no particular time. It may happen at any time. You can see the point based on the change in the requirement. The change in requirement may vary within a short period of time or after a long time. Anyway, for example, the simple example is your mobile software. Mobile software, even though it's not necessary, it's changing very frequently. So many features are updating. That is a market need. Not only due to the market need, some other reasons also there in other softwares. Because suppose if you are running an organization, you have 1,000 employees, but your business is growing very fast, your requirements may change. So this is not the same software you're going to use for the more number of you. Suppose if you create another, if you extend you extend your business in some other area, again software will change. And if you create one more outlet, if it's coming to a shop, you're going for some other outlets, again your software will change. Your needs will always change. Suppose if you have some products and you introduce some other products, your software again will change. So there are multiple reasons. Maybe technical reasons, or the customer needs may vary, user needs may vary. So there are n number of reasons for the updation. So it may happen at any time. So the failure rate, what is the failure rate? It doesn't mean that your software is completely failed. It's not needed. It's obsolete. It's not needed for your present needs. It cannot satisfy your present need. That is the obsolete software. So it may happen at any time. So failure rate is highly varying in case of software. Is it clear, this figure?
Yes,
Is it clear? So this is the difference. This is the difference between a hardware failure and software failure. In this subject, we are focusing on software, right? Then we learn about software. What is the difference between software and hardware lifetime or failure rates, and what do you mean by engineering? I mean, anyway, you are engineering students. What do you mean by engineering? Actually, in software engineering, there are two terminologies, software and engineering. So we are trying to define the subject using those two terminologies, using those two terms. What do you mean by engineering?
Developing or designing something.
Yes, you are developing or designing something. Anyway, it's a construction. It's related to construction. Okay, constructing something new using some scientific principles and methods. That is very important part. Using scientific way. The scientific name is either principle or method. You are taking the help of the scientific things, and based on that, you are developing something. That is called engineering. Development means not destruction. It's more related to the construction. So construction is something useful to your society, but you always take the help of some scientific or engineering principles. That is important. Then you call it as engineering. Scientific principles here is you can develop the same thing without those principles also. You can see some people have their own idea. They don't have any science background, but still they are having very good engineering skills. So engineering is not really related to the degree. It is your design skill. It is your idea generation. So without any engineering background, some very good engineers are in our society. They can construct so many things. They can invent so many things. But with the engineering degree, 80% engineers are not doing any kind of developments, means engineering. Suppose if you are in profession, we are doing something that is because of the particular training. Because of the training, you can develop something. But pure ideas, whoever implementing some new idea, we can call them as an engineer. Without an engineering degree, we can call them as an engineer. They have productive skill. So engineering is developing something based on some principles and scientific principles and methods. So the entire term software engineering, how can you define? You can define your own words using these two concepts. And there are many, but suppose if in exams they may ask you to define the term software engineering. It's a simple definition of what I'm going to say, but the actual definition you should write in your exam is IEEE definition, sir. That is the standard-based definition. So what is it? A normally, suppose if you can't remember anything, any kind of definition, you can write in your own way the definition. Software engineering. Developing a software using some scientific principles and methods. Okay, why are you going for scientific principles and methods? Okay, this is the software engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedure. This is the simple definition we said. It contains all the all the concepts in very simple way, but the IEEE definition is application of scientific disciplines, quantifiable approach to the development, operation, and maintenance. So this is the exact definition which you should write in the what we are expecting in the examination. The application of systematic discipline. It should be systematic, disciplined, quantifiable approach to the development, operation, and maintenance of the software. Is it clear? But if you know if you know both the terms, what is software, what is engineering, you could define in this way: engineering branch associated with development of software product using well-defined. It contains all concepts. And management and use of sound engineering principles in order to obtain economically software that's reliable and works efficiently on real machines by Fritz Bowser. Suppose if you mention anyone's name, like the scientist's name, if you mention, this is our own words. The first one is written in our own words. The second one by this particular scientist. So if you quote someone's definition, you should give the exact definition. You should not change it. And IEEE definition also, it's a standard definition. So you should not change the terminologies. The exact one you should. But in simple words, you can write the Is it clear the concept?
Yes, ma'am.
What about others? I think they went for lunch. 12:45.
No, ma'am.
No, ma'am.
Are you there? It's there. Okay. Then anyway, 12:45. The next, I think up to 12:50, right? Class.
Yes, ma'am.
Yes, ma'am.
Okay. Then any doubts on today's topic? We have only 2 classes, right, per week,
Yes,
and we
ma'am.
have one lab also. Lab also, the software engineering lab is there.
Yes, ma'am. On Thursday.
And Thursday we have lab, right?
Yes, ma'am. From 2 to 4.
2 to 4, 2 hour lab and 2 hour theory, right? Weekly 2 hours theory. 2 or 3 hours?
2 hours, ma'am.
2 hours only. Okay, last year it was 3 hours. Now it's reduced to 2 hours. Okay. So 2 hour theory and lab. Okay. Then I will continue in the next class. If you don't have any doubts right now, you can leave. And one who messaged me, what is your name? I shared the link today with someone. What's your name? Are you there? Because I need your help. I have to check once the CAS department modify. I have to check with you. The number. Who is the CR for this class?
Abhishek, ma'am. Roll number
I think
1.
probably it's Abhishek. Sorry, who shared that link?
Abhishek only shared one.
Abhishek. Okay, then that is Abhishek's number. I will contact him. Once it's updated, I will contact him because next time onwards, you can join directly from the module. Okay.
Okay, ma'am.
Okay then. Thank you.